CDR. What we can see also in this figure, so the brown area here is from the land use sector. We know that that net there, which is currently a small emission to the atmosphere, this land use term is also itself the balance between gross emissions and gross removals. And a nice aspect now from the global carbon budget update is we can actually quantify those individual terms. So we can look at kind of the last few decades of land use change. When you say land use, my mind immediately switches to think about deforestation, but this is just a reminder there's a lot more to land use. We're talking about management on agricultural land. There are some areas of reforestation and afforestation. So all of these contribute in different ways, and we know that the reforestation part of this, so the green line at the bottom, is already contributing quite a large amount of carbon removal from the atmosphere that offsets a lot of the emission from deforestation. So to some extent, CDR is happening already, and actually in reasonably large numbers, these sort of 2, 3, 4 gigatons of CO2 a year in a sustained manner on managed lands. And what we'll hear from some of the other talks, obviously, is both how the demand for CDR drives the requirement for this to grow, but also the implications and the side effects of this beyond just the carbon removal. So one of the most sort of important figures in the IPCC Working Group 1 report pertaining to CDR is this really nice synthesis of all the different kind of scopes and implications of the different techniques. So I'll take a couple of minutes just to run through the different aspects of this figure, because there's a huge amount of information summarized here. So to start with, so we see a list of different CDR methods. So we know there are some based around forestry, soils, ocean fertilization, burial in kind of geological formations. So we care about the storage permanence, and they range here from decades through to many millennia. So when you're talking about CDR methods, we do care about the permanence. We don't want to lock up huge amounts of carbon, for example, in forests that are susceptible to big fires in a few years' time. Then we care about the storage potential. So how big can any of these be? And in some way, the good news here is a lot of these are assessed to be potentially quite large, so multiple gigatons per year. Some of these compete with each other, so we maybe can't achieve all of these in addition. But there is potential, at least, for a large amount of CDR to happen in a biophysical sense. We know, though, that there are a lot of side effects and trade-offs. So as we move across the figure, I'll skip over the Earth system feedbacks. But we care about non-CO2 as well. So we need to really consider the full greenhouse gas assessment of all of these techniques. So some of these things, particularly anything agricultural-based, has big implications for things like fertilizer use, nitrogen emissions, methane emissions. Some of them, particularly in the ocean, have impacts via the ocean biogeochemistry as well. So we care about the full greenhouse gas budgeting. We also care about biophysical effects. So these are side effects that different techniques can have on particularly heat and moisture exchange with the land surface. So evapotranspiration, we care about things like irrigation, putting more water into the atmosphere, changes in albedo. If you reforest in high latitudes where there's a lot of snow cover, for example, we know that has a big impact. It darkens the surface and can cause a local warming. So there are lots of physical effects that these techniques affect. And the final column really is looking at co-benefits or trade-offs with other sectors. So whether it's water quality, food security, air quality. I think Chris is going to talk in a minute about biodiversity. So for example, if we need huge areas of land to accommodate biofuel, that's going to have a big impact on biodiversity and potentially compete with food production. So all of these kind of these trade-offs have to be considered. I think what's clear, therefore, is there's a really complex landscape of different CDR applications and techniques no single activity stands out as being able to solve the whole problem. They all have limits and implications, but they all differ, and there's going to be a lot of kind of nuanced discussion around how to apply them in a way that doesn't compromise other aspects of sustainability. So I kind of just thought I'd finish with a summary. So we know that we need some sort of CDR. So Deborah said at the beginning, it's inevitable really to reach even net zero, and potentially there's been a lot of discussion around overshoot this week as well. So to make the world net negative, we will need even greater amounts of CDR. We are already doing it on managed land, not always necessarily with this intent in mind, but globally there are amounts of CDR happening that are not insignificant. All aspects, though, have implications and costs. Some have big implications for land use, for amounts of water used, impacts on nutrient cycles, some have financial costs. So we know that no single technique can solve this on its own. There are pros and cons of each way of looking at it. And increasingly, therefore, the devil is in the detail. Like I said, we're going to need this nuanced discussion around some of the implications of all of these techniques. For example, the greenhouse gas accounting for nitrogen and methane cycles. We care about the biophysical effects, the impacts on biodiversity. And finally, is just one of the biggest research gaps really is just the uncertainty in how much CDR we will need. So we know what the central estimate is for our remaining carbon budgets, but these come with quite a large error bar. So we don't know exactly what is the carbon budget for 1.5, 2 degrees, and therefore we don't actually know how much CDR we will need to help us stay within. So all we know is that the faster we act, the deeper we cut our emissions now, the less we will have to rely on CDR going forwards, which obviously is a risk in terms of knowing the capacity and the implications of it. So CDR is not and cannot be a replacement for emissions reductions, but it is a necessary addition to them. So with that, I'll finish and pass on to Oliver. Thank you.
Thanks, Chris. That was very clear and very helpful. Working Group 1 always lays the stage for asking a critical question. So we've clearly got a small carbon budget. We clearly can't avoid CDR if we're interested in net zero because of residual emissions. We're obviously interested in issues of durability, but also the impacts that CDR has in other sectors. And so answering that so what question falls to Working Group 2 and 3. So our next speakers come from those two working groups. And I'm going to call on Oliver Gedden, who comes from Working Group 3, who's going to talk to us about how CDR now relates to this issue of mitigation. So Oliver, over to you.
Thank you. Thank you, Deborah. I'm waiting for my presentation. No, that's Chris's. Well, we get there. Maybe to start with, yeah, there it is. So I'm talking about the role of CDR and the role in mitigation strategies. And I thought it might be useful to come back to a definition. It's a common definition. The three working groups now have a common glossary, at least for the terms they all use. And the definition is anthropogenic activities removing carbon dioxide from the atmosphere and durably storing it in geological terrestrial ocean reservoirs or in products. It's of course longer, but what's important here, anthropogenic activities from the atmosphere, not from smokestacks, and durably storing it. Durably, I think, has been introduced with a special report on 1.5 degrees. Still, it's a little bit ambiguous. What exactly does it mean? It does not present a clear threshold. I think that is something that needs to be sorted out in the future. And looking at a summary for policymakers that I, on this topic, helped negotiate, a claim that has been mentioned already, and I think it's quite important to get governments to think about this productively, saying that the deployment of CDR to counterbalance hard-to-abate residual emissions is unavoidable if net zero CO2 or GHG emissions are to be achieved. So, of course, that's always kind of a bit diplomatic language. If it gets complicated, basically it says to governments, or they are saying this to themselves now via the SPM, if you have a net zero target, you implicitly already committed yourself to CDR, because otherwise it would be a zero emissions target and not a net zero emissions target. And that's the difference. So net means already some residual emissions are implied, and some, the quantification is not clear, as Chris said, will have to be counterbalanced. And of course, I'm not going to read the rest to you. We don't have time for that. But if you're interested, see 11 in the summary for policymakers. Working Group 3, by the way, does not have a carbon dioxide removal chapter. Working Group 1 does not have a carbon dioxide removal chapter. So we're presenting what we have on that topic within chapters. Here you see a conceptual figure. You should not mistake that as an actual pathway, although it looks like it. It's more about showing the components. You could read it globally. Probably you're inclined to read it like that, because they always look a little bit like this. But also ambitious national mitigation pathways have these components. And these components are, if you look at 2100, I mean, you see here no exact numbers. Non-CO2 greenhouse gases will make a large share of the so-called residual emissions. So methane from agriculture, nitrous oxide from agriculture, but also F-gases. Fossil CO2 probably also, a bit at least. Also emissions from managed land. This is everything above the zero line. And below the zero line, Chris already talked about that, we have removals on managed land already. We found it important to show that because it shifts the debate on CDR from should we really do it or not to, okay, we are actually doing it already. The question is, how do we want to go on with that in the future? And then that's the dark green area, and the light green area, other removals we're not doing already. And that leads you to the two net emissions line. And what's important here, that the dashed line, net zero CO2 emissions, goes to net zero earlier than net zero GHG emissions. Whenever you hear about a net zero target year, you should think about that. And you could basically say there are three elements for what you can use CDR, three complementary roles. Before net zero, it could accelerate your net emissions reductions. Actually, what the EU now proposed, updating its NDC from 55 to 57% reductions by 2030, would be enabled to further removals in the land use change and forestry sector. Then you needed to get to net zero CO2 or GHG, and that has been clear to many. If you want to achieve net negative emissions globally, of course you would also need a lot of CDR, but again, and Chris said that already, you can always have two sides of the coin. You can go down with the residual emissions further, or upscale CDR. People often ask about exact numbers. So what does the IPCC says, how much CDR do we need, or make claims? I mean, there's now a growing CDR community and saying, yeah, the IPCC says we need 20 gigatons or 10 gigatons. Actually, we don't even say it. Even if we had a number, it would be a little bit misleading to use it. So on the left hand, what you have, it's a so-called illustrative mitigation pathways. There are 5 of them, different strategies to go to net zero CO2 in that case. So all the colored elements above and below the zero line. And I will not go through the colors, but it shows there are different ways to get to net zero CO2 and different ways what kind of residual emissions to have, what kind of removals to have, and what the numbers would be. You see there are pathways, illustrative pathways, with only low levels of residual emissions and removals, and also with quite high levels. Again, important to see the gray area is the non-CO2 that comes on top. On the right hand, you see for BECS, bioenergy with CCS, DAX, and net removals from agriculture, forestry, and land use, what the scenarios, the integrated assessment model scenarios show. But you should not overinterpret these numbers because it's not a statistically controlled database. Many of these IAM scenarios had a lot of bioenergy with CCS, but you cannot therefore say the IPCC says we need to reach this. That's why we have these IMPs to show variations of strategies where in the database you have clusters of strategies that a little bit bias the whole database towards specs. Here you see a little bit more fine-grained than Chris's figure, not only a cluster of methods, but also implementation options that differ. Even for, let's say, a method like direct air capture with carbon capture and storage, you have different technology routes with different energy requirements. But again, here the clustering and the quantification is not around the usual nature-based or ecosystem-based versus technological, but the removal process in a very sciencey way, but also the timescales of storage, because the main benefit is to remove CO2 and store it away. One aspect we will get to, that for some methods, the biological methods, vulnerability to reversal, it's a major concern if you store it in vegetations or soils and sediments. And an often asked question, what about CCS, CCU? Can be a component of a carbon dioxide removal method, but only if the CO2 comes from the atmosphere, not from a fossil-fueled process. I will not go into detail here. This is the non-typeset version we still have to work with. We have the typeset already. I'm not allowed to show it. But that's the way we do method assessments for technology readiness levels, for costs, potentials, side effects, co-benefits. So we do all that in the report, and I think in 2 months' time we will have much nicer tables on that. And finally, research needs and knowledge gaps. I already mentioned one point, the definition of durability, or at least a better distinguishing of durability clusters. It's also something that will happen in countries that will develop proactive carbon dioxide removal policy. Monitoring, reporting, and verification of carbon flows is always important, but here it's especially important because if you just don't emit a ton of CO2, you know it has not been emitted. If you remove it, you have to follow that ton of CO2 for quite some time to know it's still out of the system. Pathways, the usual stuff, effectiveness of methods, costs and potentials, risks, co-benefits of deployment. Of course, it varies by scale, it varies by location. We tend to say, yeah, large scale is especially problematic, but you can do, of course, do things wrong only also on low scales. A big discussion that will follow from that SPM, residual emissions, supply removals, is what do we actually count as residual emissions? Because for some industry, that might look like an easy way out. The IPCC says our emissions are residual emissions. And finally, governance and policy, feasibility, sustainability constraints, risk and co-benefits, important dimensions across all 3 working groups right now, and a special report on land, certification and accounting, and targeted incentives, of course. Thank you.
Thanks so much, Oliver. And I think the ambition of this side event, as I indicated, is we really want to take this discussion from modeling through to the real world. And I think Oliver's given us some important cautionary notes about how we interpret the models and bring them into the real world. But one of the things that the 6th assessment cycle really indicated to us is that in the real world, adaptation and mitigation interact. They don't exist in silos. And so my next speaker, Chris Tresos from Working Group 2, it's good to have another Working Group 2 colleague here, we'll be talking to some of those consequences. So we've got a limited carbon budget. There are opportunities for mitigation, but depending how ambitious you are, there are implications in terms of the amount of CDR you need. But what we've learnt in Working Group 2 is that responses also have consequences. And so I'm going to call on Chris, who's one of our CLAs from Working Group 2, and like Chris Jones and Oliver is also busy working on our synthesis report for us. So thank you for that. So Chris, can I ask you to talk to the relationship between CDR and ecosystems?
Thanks, Deborah, and thanks all of you for joining us on this important topic. So I'll be talking about CDR in the context of ecosystems, bringing in some of the adaptation story around co-benefits or trade-offs, and then also looking at where CDR might generate new risks or opportunities on a landscape. So this figure is from the Africa chapter of Working Group 2, and it looks at the nationally determined contributions from 52 African countries. And there are a few takeaways here. The first is that about just over a third of what African countries are listing as adaptation opportunities in their nationally determined contributions are what we might call ecosystem-based adaptation. And particularly in the context of CDR, when we're thinking about carbon removal in the land sector around vegetation and soils, there's a potential large synergy there, as Chris Jones mentioned in his first talk, but there are also potentially some substantial trade-offs. And you'll see in that area, like Oliver was saying, where in managed systems there's already carbon dioxide removal happening. A lot of African countries and others are talking about ecosystem-based adaptation in the agriculture sector, in forestry and other land use, environment and water, much less in other sectors such as urban or tourism. We might argue that they should be doing more thinking about ecosystem-based adaptations in those areas, but right now it's very focused around the land sector. And so this does generate a number of opportunities where mitigation and adaptation might go hand in hand, such as around things like flood protection using natural ecosystems like mangroves or seagrass ecosystems that can have quite high carbon storage capacity locally, but they do not compensate for continued fossil fuel emissions. These aren't silver bullets in the land sector, as previous speakers have said. This is something that we should be first halting deforestation to prevent additional emissions, and then the land sector in enhancing CDR might be something that can help us get to net zero. However, there are risks around that. And so this is a map globally looking at grassy biomes such as savannas or grasslands in green, and in the purple color is areas of what might be termed degraded ecosystems, but if you live in those ecosystems like a grassland in Ethiopia or a savanna in Kenya, you know that these are ancient ecosystems that have adapted and evolved in the context of mega herbivores and regular wildfires, and they're not degraded, they have their endemic biodiversity. Millions of people depend on them for their livelihoods, such as through agropastoral contexts. And those purple patches are showing where a afforestation campaign could be at risk of planting trees in naturally unforested ecosystems. And so that can exacerbate climate change risks to food security, to water security, and present risks to local biodiversity through habitat transformation. Africa is particularly at risk from this type of afforestation, but you can see that it's widespread on every continent except Antarctica. So these are, as we discuss some of those trade-offs of how much CDR might be needed for a net zero CO2 or GHG, there's a strong conversation here about where, if we're using things like afforestation as a fairly substantial component of that, where on the landscape are those trees going? Are they going into ecosystems that are not naturally forested? Another part here, it's not just grassy biomes. Peatlands may be equally at risk of this type of thing. For example, in parts of the UK and Europe where tree planting has happened in peatlands. One other thing I'll mention is that and this is assessed to some extent in IPCC, but trees, when we have pledges around, okay, we're planting 50 billion trees, that's really 50 billion seedlings. And that takes a long time to turn into some smaller number of billions of large mature trees. So it's using these ecosystems have limits. Like global warming above a certain level places more extreme risks of things like wildfires or drought or pest outbreaks that can reduce the durability of these sinks for us. And at the same time, it takes a long time for an afforestation campaign to soak up that CO2 from the atmosphere. It's not something that happens now. If you emit now, you're only getting that removal of the CO2 decades later. And so in that context, when we think about afforestation, the Working Group 2 assessment makes the finding in its summary for policymakers that at small to large scales, so right across the scales, planting trees in ecosystems that are naturally unforested, while it might yield some carbon removal benefit, presents a risk to biodiversity, food security and water security, as well as in areas where indigenous peoples manage the land or where there's uncertain land tenure, they can have very serious negative consequences for local livelihoods. So if we shift from afforestation to reforestation and ecosystem restoration, which is something that the Working Group 2 report talks about as a good thing, both for adaptation and mitigation, we still need to be very careful when we're talking reforestation. Where are we planting these trees and what kinds of forests are we restoring? So on the left here, you see an image of a native forest. So reforestation with indigenous trees in the correct types of habitats with a diversity of species is assessed to potentially be more resilient to future climate shocks and things like disease outbreaks, as opposed to plantation forestry, where you have often single species monocultures planted over large areas that often require things like fertilization for those trees to grow faster. And in cases where you're not planting them from seeds, but doing vegetative propagation, those individuals in a plantation will be genetically identical, and so something like a pest outbreak that moves through can take out a very large proportion of that plantation in a very short period of time. So plantation forestry, if we're thinking about durability, is potentially much less durable on a landscape, especially under future higher global warming levels. And so for a final thought, I think ecosystem-based adaptation with CDR co-benefits do exist. However, the higher those what we consider residual emissions are, and the higher we let global warming get, the more limited we are able to draw on these co-benefits and use natural ecosystems as part of the CDR portfolio. And then finally, involving local communities and including indigenous knowledge systems around things like planting indigenous trees, fostering local biodiversity is a really crucial part of an ecosystem restoration and CDR co-benefit strategy. Thank you.
Thanks so much, Chris. And I think that presentation helped us to understand, building on the limited carbon budget, the fact that CDR is unavoidable if we're interested in net zero, that while CDR is important, it can't only be about carbon. We've got to think about these responses in the context of the communities in which these actions occur, the impact on the ecosystems, in order to have a systemic approach to this particular challenge. So I think that's one myth we're busting. We do, in fact, have a gender-balanced panel, I'm delighted to say. And I would like to call up as our next speaker. She's coming in virtually from Brazil, Jana Portugal Pereira, who, as with women, has multitasked throughout this assessment cycle. Not only has she been involved as a lead author, she's been involved in our special report on land, but she's also played a key role in the Working Group 3 TSU. And so I'd like to call on Jana to talk to us about the issues associated with the large-scale expansion of CDR. Jana, are you there?
Yes, Deborah, can you hear me all in the room?
Yes, lovely, I can hear you. I can't see you. Jasmine's working on it.
Well, yeah, okay. Thank you, Deborah, for the kind invitation. Good to see you, although you can't see me yet. Thank you very much, organizers, for inviting me to be here discussing such a relevant issue within the 6th assessment report in IPCC and goes beyond in terms of negotiations and climate action. So I'm here today from Rio de Janeiro Federal University. Unfortunately, I couldn't be there in person to share with you key findings that were assessed in the special report for climate change and land. This special report was co-governed by
Joanna,
the three
can you just
groups.
hold on? We're still not seeing your slides. We've just got them now. Is this the first slide, Jasmine? Yeah.
Exactly.
Great. Great. We can see you and the slides now, which is great. Thanks very much.
Perfect. Thank you, Deborah. This is actually my first slide, and I was just mentioned that the special report on climate change and lands was developed with the 3 working groups, so with co-governance from the climate science, adaptation, and mitigation to evaluate interactions between climate change and land uses. So within this report, we evaluate pathways to stabilize global warming to 1.5 or well below 2 degrees, and what kind of land-based mitigation landscapes are required. Here in this presentation, I will show you the summary for model pathways that were developed with frameworks based on integrated assessment models. And a key finding is all model pathways to achieve 1.5 degrees by the end of the century, they to some extent are dependent of carbon dioxide removal strategies. And the sooner we act on climate reduction emissions, the lower dependence we have on these strategies and the lower impact or potential trade-off effect we have with other ecosystem services. So meaning when we delay action, we actually require larger scale of conversion of land that implies negative consequences to terrestrial ecosystem service, as was highlighted by previous speaker. So different storylines, even if we develop models that all have carbon budgets in line with 1.5 degrees, different pathways are forecasted to achieve these storylines and these carbon budgets. And all the 3 storylines evaluated to 1.5 degrees, they actually depend, or to some extent, to carbon dioxide removal. So if we think about the shared socioeconomic pathway 1, that assumes a more sustainable future, sustainable land management and sustainable intensification of land, we actually see a lower requirements for pasture and crop, assuming higher productivity and intensity of land use, and we would actually have available land to increase bioenergy and forestry from afforestation. And overall, up to 2050, the land required for forest and bioenergy in this pathway would reach around 5.5 billion square kilometers. However, following a historical trend that is represented by an SSP2, where we see a higher dependence on technological developments and an increasing demand for land mitigation options, mainly focused on bioenergy and afforestation, we actually see a much higher land requirements and land use change to increase the areas for bioenergy and afforestation. And in this specific pathway, we also see, following historical trends, decrease of native species, which means a high rate of deforestation, which is clearly not the correct pathway that we want to achieve in future. And following an SSP5, that actually it's a storyline that assumes a very intensive use of resources and fossil fuels and high consumption patterns of the society. In this case, we would actually require higher land for afforestation and bioenergy that could nearly reach 10 million square kilometers. And this, just to put you in a perspective and scale, this is higher than Brazil, a continental country here in South America. So in terms of how feasible it is and in terms of potential consequences, if we follow this pathway that actually delays climate action, is clearly dangerous, and the science doesn't have responses yet to evaluate the future implications of this. Also, in the special report for lands, we compare different global warming levels represented here by representative concentration pathways, meaning 1.9 nearly close to 1.5 degrees Celsius up to 4.5 and the baseline trend. And we clearly see a lower dependence on land for bioenergy and deforestation and carbon dioxide removals if we follow baseline trends. But actually, these pathways entail higher climate impacts that were not included in the integrated assessment pathways. So to summarize, if we model higher global warming levels represented here by baseline or RCP 4.5, we actually are less dependent on land for reforestation and bioenergy, but that also entails significant impacts to the global climate change and ecosystem services that were not included in the assessment. Just to zoom it in, I actually compare the land implications and landscapes in different global warming levels under SSP2. And as I just mentioned, if we consider a world that stabilized global warming in 1.5, it's the first two bars you see on the left-hand side of the figure compared to a baseline or RCP 4.4, comparing bioenergy demand, bioenergy land demand and land for reforestation. You clearly see an increasing requirements of land for lower global warming levels. But again, as I just mentioned, that actually does not include and model the foreseen impacts in terms of climate to upper levels of global warming. So we also evaluate the scale requirements. So actually bioenergy and afforestation and other land use practice, they can actually be implemented in a sustainable way if they are implemented at a lower scale with specific social, economic and governance contexts that are inclusive and include local people and local governments that are involved in the area itself. So what you see here in these two bars, the upper one for bioenergy with BACs and afforestation, the upper one imply the interlinkage, co-benefits and potential trade-off effects of large-scale implementation of bioenergy and afforestation, and the clear potential impacts in terms of adaptation, desertification, land degradation, and negative impacts for food security that are highlighted in red here. On the other hand, if implemented at a smaller scale with concrete strategies and governments to include local people and other ecosystem services priorities, what you can see at the bottom level, actually you see bars with green in terms of mitigation, adaptation, desertification, and reduction of land degradation. That actually means that best practice and sustainable practice can actually be positive both for mitigation and adaptation. Very clearly, it's very context specific for good governance and other socioeconomic parameters. So as my takeaway message and key findings from the special report on climate change and land, firstly, we evaluate integrated assessment model pathways, and the deployment of CDR actually is required in all mitigation pathways that were assessed. However, the dependence on those actually depends on how fast climate action starts. And on the other hand, if we delay climate action, we may be more dependent on carbon dioxide removal strategies, higher amounts of land that clearly has negative impacts with other ecosystem services and other sustainable development priorities. So the pathways with large levels of land conversion and dependence on carbon dioxide removals have clear adverse side effects in terms of water scarcity, biodiversity, land degradation, increasing acceleration of desertification, and food security. So a key message that we bring from this special report is actually to have inclusive governance strategies to ensure that bioenergy, afforestation, and other land-based carbon dioxide removals are actually implemented in a sustainable way. Thank you very much. I can't see you now, Deborah, and the panel, but over to you.
Super, thank you, Joanna, and thank you for really developing some of the messages that we've heard already, that there are real consequences if we don't mitigate early. Because if we're still serious about net zero, that is going to require increased carbon dioxide removal. And the consequences, I think we saw in some of those figures, the scale of the land that would be required if we weren't ambitiously mitigating, begins to raise real questions. A great deal has been made. This is the African COP. Certainly, I would imagine for policymakers in Africa, seeing that level of land conversion being proposed, I think would make policymakers quite nervous in Africa. So there are real consequences in the real world. This is not only about models, this is not only about carbon, this is about people and places and changes in the way people lead their lives, their livelihoods and their futures. And it's really that we have to think about, that entire story around carbon dioxide removal that I think our presenters have brought to this particular side event. So thank you very much for that. We're doing reasonably well for time. So what I'd like to do now is, you've heard the story that's been told by our four presenters, is really open to the floor the opportunity for questions. You've a lot of information, a lot of models, a lot of figures. What's your burning question, having seen these presentations? Do we have a roving mic available? So let's start off with Diana. Go ahead, Diana.
Let's start not
Okay. We've got a very gracious IPCC Vice Chair who's relinquishing the microphone. If you could introduce who you are and where you come from before you ask your question, that'd be useful. And indicate if there's a particular presenter you want to direct your question to.
Yes, thank you. My name is Wim Carton, Lund University. So thank you very much for the presentations. I'm wondering, maybe this is mainly for Joanna, actually, and I probably should go back and read the special report on land myself, but me and a few colleagues did a land gap report a couple of weeks ago that we released, where we calculated all of the implied land requirements for removals from the NDCs and the net zero targets from all the countries, at least to the extent that those have been specified. And we found in that report, which is available online, and we had a side event here, and Mike, a little pitch for the report, that there's 1.2 billion hectares of land implied for removals, half of which would be land use change, mainly afforestation, and roughly half of which would be some form of restoration, which, as Chris mentioned, then of course still is the question, like, what does degraded land and so on mean? So my question is, if I understand the different pathways that you presented, Joanna, that 1.2 billion hectares would be higher than the largest pathway that you've presented, if I have my conversion of square kilometers to hectares right. So I would just like to hear, like, your reaction to this, if these numbers hold, noting of course that the NDCs are vague and there's a lot of assumptions and so on, but still, I guess it gives an indication. So I'm keen to hear your thoughts. Thanks.
Joanna, do you want to come in on that?
Yes, thank you, Deborah. Thank you, Jan. It's difficult for me to comment on numbers in a report that I haven't seen. So I invite Jan, if you could somehow, to the organizers there in the meeting, to share your report, and then I could give you a more concrete comparison of those. The numbers I showed were for global warming potentials up to 1.5. Not really sure if your report includes those or not. And another important aspect to ensure we can actually compare numbers is this report does not integrate the latest integrated assessment model scenarios and carbon budgets presented in Working Group 1.1, so presented here by Chris, and the mitigation pathways presented by Oliver from the Working Group 3 report, because this was published before that. It was approved and published by the panel in 2019.
Thanks, Joanna. And I think there's a useful, perhaps offline conversation around the numbers, because policymakers are always used to numbers or interested in numbers, so it'd be great to get clarity on that. I think the next hand was from Diana.
Thank you, Diana Rugeforst, Vice Chair of Working Group 3. And I also have a number of questions, so it may, again, not be possible to answer both to Joanna and Chris. You both mentioned that there can be negative and positive impacts. Well, also Oliver mentioned, but you particularly talked about land-based. But you did allude to that if we do this well, there are some areas where this could be done with mostly positive impacts. And the question is, would you have any number of what's the limit to, let's assume we are all really good boys and girls and we are really, we trust our policymakers that they will do the afforestation the reforestation in a way how you would consider it the most positive. What would be the top number for such a positive type of CDR? Do we have any numbers on that?
Are you meaning in terms of tons of CO2 that could be... On that, I would refer to Jona. I think when it comes to land surface potential in an African context as shown from that map, I think the actual land available for what, from an ecological perspective, I would, as an African ecologist, call restoration, is much more limited than what we talk about as available for reforestation and afforestation, partly because of these issues around what counts as degraded as opposed to what is naturally something like a savanna ecosystem. But on carbon removal numbers, I'd definitely hand that over to a Working Group 3 colleague.
Joanna, do you want to come in on that? Any figures on what good carbon removal might look like in terms of reforestation, etc.?
Oh, thank you, Deborah. Thank you, Diana, for the question. I can't see you. Very good that you are here in this panel. Numbers in terms of potential for bioenergy with CCS, they vary widely from 100 to 900 exajoules yearly. A common number found in literature refers to 200 exajoules as the sustainable upper limit to have bioenergy and CCS with limited implications with other ecosystem services. In the Working Group 3, AR6, one of the IMPs, the ninth one, if I remember correctly, C2, actually assumes higher dependence for carbon dioxide removal strategies, and the carbon dioxide removal rate yearly is between 8 to 10 gigatons of CO2 equivalent, with the caveat that's actually the upper limit and does not mean it's sustainable itself. It means it's in IM world possible to have it. It's very different to be plausible in the real world.
Super. Thank you, Joanna. Chris, do you want to come back in?
One thought linked to where Oliver was talking about future research. I think something where the IAMs could really improve is, to my knowledge, the ones currently don't include many feedbacks from extreme climate events onto the land surface. And so that would really improve our understanding of potentials, as well as actually in the current land use harmonization data sets that come out of those and go into the Working Group 1 models. Some of the IAMs do this, others don't, but explicitly track afforestation as opposed to reforestation/restoration. In many of the IAMs, that's just currently one category, and I think kind of being more precise about that in the next round of IAMs and going to AR7 would help us a lot to answer your question.
Super. Oliver, do you want to come in?
Yeah, maybe to add on that, I think the granularity of the information needs to be improved. Many of the IAMs only report net fluxes on land, so we then don't really see if what you see as an increasing removal is actually decreasing deforestation. So I think we need a better reporting there. What do we actually have? It would also enable us to see what do IAMs assume in the second half of the century in terms of removal potential? Because there has been a lot of criticism that these numbers might be unrealistic, given a warming climate. I think I have seen some modeling experiments showing, okay, maybe IAMs did not get it wrong. In the second half of the century, the more technological removals seem to pick up. But I think there's a lot of room for improvement, how the IPCC presents these numbers. Another addition, Joanna, of course, showed also the land needed for bioenergy that is not used for carbon dioxide removal. And in many integrated assessment models, if you go down with the levels of BECCS, the bioenergy or the biomass might shift into other areas. So I think there we should not, let's say, equal bioenergy with carbon dioxide removal. I think there's a lot of improvement to be done on the modeling side, but I think it's good that we have the increasing pressure from policy reports, but also policymakers. What would that look like on the ground? And also, what is the regional distribution of that CDR? Because most of it's not going to happen in the global north.
Chris, I see you've opened your camera. Chris Jones, do you want to come in?
I was mainly just making myself visible to be part of the conversation.
Great.
But I think the other thing we've looked at is, I don't have numbers to hand, but looking at things like biofuel productivity on marginal lands. So trying to make sure that, these things are not invading, prime agricultural land and competing for food. And, there is significant potential. Like I said, I can't remember the numbers on this to start really thinking about biofuels on some of the marginal land and abandoned lands.
Super, thanks, Chris. We've got a hand at the back.
Thanks. Mariana Tikkanen from Puro Earth, and for the last 3 years we have been in commercial operation crediting carbon removals, technical carbon removals, and one of the fastest growing areas is biochar, very often made from agricultural wastes and then put back to lands that benefit from it. That's sort of fallen through the cracks here, so I would like to hear comments on that, and will it be covered in a revised version?
Yeah, maybe I'll start and then Joanna can add on that. Biochar is not a standard element of integrated assessment modeling. This is about to change. But in the IPCC report and that preliminary table I showed you, there is an assessment of the potentials of biochar, and the co-benefits could really be high depending on the biomass feedstock. And also I think the global numbers of use of biochar for different use cases, for example as fertilizer, especially in China, or as an add-on to fertilizer use, will increase attention there. But it's one of the areas where we see much action, but I think the numbers for potentials are still quite, let's say, not very robust, and the whole CDR assessment in the IPCC, which is always an assessment of the existing literature, will of course profit from an increasing use of novel CDR methods in the real world, and studies then tracking and assessing that use.
Joanna, do you want to come in on the biochar issue?
Thank you, Deborah. Actually, Oliver, our national level integrated assessment model in Brazil includes biochar as one of the options, among others, and is actually one of the options selected when we want to forecast 1.5 global warmings. But at a global level, I agree with you, most of models do not assess biochar, and other more specific CDR options such as agroforestry or sustainable intensification of land use with enough detail that can be represented in those. And even if they were, integrated assessment models are highly aggregated, dividing the world in 18 or 20 regions. So very likely it won't give you the solutions and answers that you are looking for if you think a specific municipal or a local region in a sub-national level.
Thanks. Chris Jones, I see your hand is up.
Yeah, thanks. I mean, I was just going to add, I think Oliver covered most of it actually. I mean, biochar is in the Working Group 1 assessment. It has a moderate potential, but it is one of the techniques that has very few trade-offs actually. Most of the columns kind of list it as having co-benefits on, nutrient supply, kind of fertility of the land, water quality. So it's definitely one that should be considered, but it is part of the assessment. It's not been forgotten.
Great, thanks for that.
Yeah, hi. My name is Jan Wilkins from the University of Hamburg. I wanted to ask you, I think you made a very interesting point that the definition of durability is a challenge, and I was wondering if you could say a few more words on this. Kind of what are the parameters that it makes it difficult, or where are the kind of the points of contention? Thank you.
Well, I think we're going to find out what the points of contention are in, let's say, national debates. I think it was good that SR 1.5 introduced that simple word, durable, to distinguish it from other methods like carbon capture and utilization, for example, where you would, for example, with direct air capture source, remove CO2 from ambient air, but maybe use it for the production of synthetic fuels, and then the CO2 shows up in the atmosphere 3 weeks later. That's not removal with low carbon or zero carbon energy. That could be at best be net zero, which is also compared to fossil fuel kerosene an improvement, of course. I think that there is an ongoing debate what should be a threshold to count as real carbon dioxide removal. Some people saying, okay, a climate relevant time scale could be 1,000 years, but then every method expert scans, okay, do we reach that level or not? And may go lower. I think there is we should avoid to look at it in an either or logic. I mean, let's say a term like permanence would kind of carry that logic with it. Either it's permanent, then it's okay. It's not permanent, we don't use it. I think if it's below a certain threshold, and now let's work with that ballpark number of 1,000 years. Biochar might run into some problem depending on how exactly you would deploy it. Of course, everything in forestry would run into problems. But you could say there might be still use cases, but you have to create accounting systems that allow you to work with that, which then but might create additional, let's say, administrative burdens for MRV, how to track that, which might make the option itself less attractive as carbon dioxide removal option, but then there are all the co-benefits. So it could be that, and probably we should do ecosystem restoration for 10 other reasons than for carbon removal, although it has that effect. But as we all know, once you create accounting rules, and once it's in the inventory rules of the UNFCCC, project developers think in these numbers and will act accordingly. So I think this demand for exact delineations will come partly from the voluntary carbon market actors, but I think in the medium term from countries and governments who actually want to integrate carbon dioxide removal into the mitigation policies. For example, the European Union, or specifically the European Commission, will introduce a draft legal act for the certification of carbon dioxide removal to develop methodologies. Again, for LULUCF, we kind of have them already because LULUCF is already, at least most of it, integrated in national inventories. But for example, direct air capture with carbon capture and storage, we don't. And the whole debate about the problem with terrestrial removals could also lead us to thinking, okay, maybe we move to carbon dioxide removals that don't have the direct land competition. But quite often then you run into other trade-offs with energy use or indirect land competition. So I think policymakers will explore the whole range of methods and trade-offs and synergies, and they will do it in different ways, as we see with other mitigation options. And in the next cycle, the IPCC simply has to follow that literature closely to refine the assessment.
Thanks, Oliver. And I can say, as someone who initiated a large-scale reforestation project, the transaction costs of keeping that carbon in the forest are absolutely enormous. And I don't think we've thought through the implications for government of committing to keep carbon in a forest for 1,000 years. And I think that's the full cycle we've got to think about, and we've emphasized in the side of it. It's not only about carbon, but people, places, the governance, the resources required to hold that carbon in place. We had a hand over here.
Hey, thanks a lot for those presentations. I'm Harold Beer from the European Biochar Industry Consortium, so the European Association. And naturally, my most pressing question revolves around that topic. And in this case, it's I see biochar as a biochar application positioned in the IPCC. But if you consider carbonization as a process, it's an exothermal process, kind of like bioenergy carbon capture and storage. You spend large parts of the carbon for heat production, energy production, and you conserve about 40% in a carbonaceous material that's very rich in carbon. You can use that in different applications, but you have actually an energy production that you can use for heat or for electricity. Is that considered? Because I don't really see it. And if we do, I think we could reconsider the potential, because the potential seems to be displayed as something rather low, and the potential for BECCS rather high. But if you use biomass for a carbonization process, as I said, you do have energy production. Just the output would not be ashes, but a carbonaceous, highly interesting material for a post-fossil economy. Maybe that would be something to consider. And the other thing, just an add-on, we now get evidence from other scientific disciplines than soil experts on the permanence, and it seems to be the most stable form of carbon that exists on the Earth. So that will be also something that would be fed in, and I would like to share this information already promised. Thanks.
Oliver, I think that's you.
I mean, we run into the usual discussion where method experts like kind of promote their beloved method, but I can assure you that in Working Group 3, Annette Cowie from Australia did the biochar assessment, and in the end we can only, and I think, put more biochar in there than many would have imagined. I think in the future the representation of CDR methods in integrated assessment modeling has to improve and will improve, because basically it's right now sorry, it's the second week, I already lose my voice. And it seems I don't make it to this last event. I think we will have more methods, we will need more application and more literature assessing that, and that is basically the decision point the IPCC can make. So if there are new developments, we will of course cover it, and maybe Joanna has some additional thoughts.
Joanna, would you want to come in?
Thank you, Deborah. I absolutely agree with you, Oliver. I'd like to highlight and remember everyone in the room that IPCC doesn't develop original science. So we do a systematic literature review. So if there's gaps in the literature, and that's why last slide from Oliver is extremely important for the scientists in the room and for ourselves. If we identify gaps in the AR6 that were already highlighted here, they should be covered in publications, peer-reviewed articles that will surely be assessed in the next cycle.
Thanks so much, Joanna. Do we have any other questions from the audience? Over here, please.
Hi, I'm Jessie O'Reilly from Indiana University. Thank you. This was really interesting, hearing from all three of the working groups on this topic. I have two questions. One is, at what point did CDR become inevitable? It seems to me, but probably from a position of ignorance, that as soon as it was being assessed, it seemed inevitable. But I would love to hear a little more about how that developed, how we got to that so apparently quickly. The second question is, there seems to be at least two communities involved, sort of the afforestation, reforestation, ecology, ecological restoration community, and then the more tech side of it. I'm wondering how these groups interact besides in this panel. And in, I think, maybe some cross-chapter boxes in the IPCC, but also how they show up in the IAMs. So is CDR modeled, like, are both of these approaches included differently in the model? Are they thought about differently in these future projections? Thanks.
Thanks so much. Who wants to start with Chris? Okay. Joanna, Chris Tresos is volunteering you again. The first question relates to when did CDR start featuring, and I see Chris Jones has raised his hand as well. So Joanna, any comments, or do you want me to pass across to Chris Jones?
Yeah, thank you, Deborah. Well, don't really know when CDR was born, actually before me, I believe. I can't really tell. I move it to Chris if he's more aware of the historical evolution of CDR. I'd like to clarify something again. CDR per se is not negative. It's such like land use change. It's not negative per se. It can be positive if we are thinking, for instance, that restoring land, as was presented by Chris here in the panel, or if we are increasing intensification of the land use in a sustainable way. Here in Brazil, we have millions of hectares of degraded pasture. So when we talk about land use change, it's actually ensuring that that pasture is restored and change with native species in the ecosystem. So that's something that I would like to highlight. A second question about integrated assessment model, I believe I missed it, so I'm not really sure what was the question, but just to remember everyone in the room that integrated assessment models, they are mainly process-based methodologies, and they are very focused on technology and energy supply. So they were originally developed in the 70s, and the main focus is energy security. Over time, in IPCC and other global assessment institutions, they become more relevant in terms of assessment, and they are actually now starting to integrate other sustainable development dimensions that were not included at the first place by the models, where there's still a long way to go to ensure we have plausible pathways and we can aggregate all variables and parameters required. Thank you. Over to you, Deborah.
Thanks so much. Chris Jones, could you come in here?
Thanks. Yeah, it's a really interesting question. When did it become inevitable? And thinking from a kind of biophysical point of view, it's always been inevitable that to stabilize global warming, we have to stop emitting. So net zero is a requirement to stop warming at whatever level. It's 1.5, 2.5, 4 degrees, whatever. We have to stop emitting, or we'll keep warming. So if we accept that we can't get to net zero by completely decarbonising every sector, some element of CDR has always been a requirement. So maybe it's been a gradual realisation of that. rather than a new thing per se. But the key thing is it's not a binary thing, do we need CDR or not? It's about the magnitude of it. And what has grown rapidly is the amount of CDR required grows for every year we don't stop emitting. And I think it's that, so the whole debate does tend to polarize people because there is this moral hazard angle that just discussing CDR takes some of the focus off the fact we need to reduce emissions. And, you know, for a lot of people, it's seen as a sellout that we're even discussing it. You know, so what we all are clear on, I think, is CDR is not a replacement to stop emitting. You know, that is crystal clear. And the more we don't stop emitting, the more we're opening ourselves up to a requirement for CDR. And on the magnitudes that we're talking about, the trade-offs and the downsides of it become more and more of a risk. So I think we should stop seeing it as a do we need it, yes or no, to about how much we need it. And the more we can stop our emissions, the more we reduce our reliance on it, and the more we can avoid some of the, you know, the more detrimental side effects of it.
Thanks, Chris. We've effectively run out of time, and we feel like we're living in the middle of a music concert currently here on this side. So I'd like to take this opportunity to thank our 4 speakers today, the 2 Chris's, Joanna and Oliver, for not only their inputs, but engaging with the questions in such a robust and entertaining manner. I think what this side event has pointed us to is the fact that once you move beyond the graphs and the models, you're in the real world where decisions are complex. One is going to have to be vigilant about approaches, location, scale, consequences, implications, synergies and trade-offs. And I think it's just an underscoring at the end of what I think has been quite a challenging COP, of the challenging road that lies ahead. There are no easy answers left anymore, and I think this particular side event has underscored that we need to be vigilant, we need to be thoughtful, we need to be open-minded, and at all times thinking beyond carbon, because climate change long ago ceased about being just about carbon alone. It's now about so much more. It's about economies, peoples, and places. So thank you very much for your attention and making time for us at the end of the COP. And again, a final round of applause for our speakers, please. Thank you. Bye, Joanna and Chris on screen.
Thank you.
Goodbye, everyone. Thank you.
Bye.